Today's lesson is on factoring polynomials. So before we get started on the examples, let's take a look at this. So what I have here is a graphic organizer of every way that we've learned how to factor this year. So if you follow the graphic organizer, the first thing you always check for is your GCF. After you take out your GCF, you identify, are you working with 2 terms or are you working with 3 terms? If you're working with 2 terms, you need to look for a pattern. Are you dealing with squares or are you dealing with cubes? And I have your formulas typed in right here. So that's actually what we went over yesterday. Over here, if you're dealing with 3 terms, that's when you do your A times C method. You multiply to whatever your B value is. Sorry, you multiply to whatever that value is and adds to your B value. And then you factor by grouping. So this is just how we factored. It's every method that we've learned so far. We are going to throw one more thing in here. So previously with your A times C method, it's A times x squared plus bx plus c. Now you're going to see the same exact pattern, so the same way of factoring, but your exponents are now going to be larger. So this same process works when you start with an exponent of 4 and your middle exponent is 2. Basically, it works every time your second exponent is half of the first exponent. So half of 4 is 2. If we look at originally, half of 2 is 1. So anytime you have that pattern of exponents, you can use the same process. For example, let's take a look at this first one. We have x to the 4th plus 7x squared plus 10. So yes, we need to pay attention to our exponents, but we're looking at the same process that we've been factoring all year, and we've done this so much, so everyone should be well aware of what I'm doing here. A times c, in this case, is 1 times 10, which is equal to 10. So I need to find the 2 factors that multiply to equal positive 10, and the same 2 factors that add to equal the middle number of 7. So in this case, it's going to be positive 5 and positive 2. 5 times 2 is 10, 5 plus 2 is 7. So pay close attention to your exponents and rewrite your function. We're starting with x to the 4th. So when I rewrite this, I have x to the 4th plus 5x squared plus 2x squared plus 10. So this middle term is the same as these 2 terms there. Just be very, very careful. I can't stress it enough. Just check your exponents. Make sure they match all the way through the problem. Yes, we're using the same exact process that we've already used, but you have to check to make sure you're doing it right. You group your first 2 terms. You group your second 2 terms. The GCF of the first group is now going to be x squared. You can take out 2 values of x from both terms. Left over is x squared plus 5. GCF of the second group is positive 2. Left over is x squared plus 5. Here's your common factor. There's your GCFs. We can write this as x squared plus 5 multiplied by x squared plus 2. The first factor of x squared plus 5 is your common factor, and x squared plus 2 are your GCFs. That's your final answer. Number 2 is 4x squared minus 20x to the 4th plus 24 times x squared. So we do have a GCF here. We can take out a factor of 4x squared. When we take out 4x squared, our first term is left with x to the 4th. Our second term is 5x squared. And our third term is 6, just 6. At this point, we need to factor the second part. So I need to do a times c, which is 6. What 2 factors multiply to 6, and the same 2 factors that add to equal negative 5. This would be negative 2 and negative 3. You need it to multiply out to positive 6. So negative 2 times negative 3 is positive 6. x to the fourth minus 2x squared minus 3x squared plus 6. Be careful with your exponents. Group your terms. GCF of the first group is x squared. Left is x squared minus 2. GCF of the second group is negative 3. Left over is x squared minus 2. Here's your common factor. Here's your GCF. Don't forget your greatest common factor that you took out at the beginning, which is 4x squared. And then I'm going to multiply x squared minus 2 and x squared minus 3. X squared minus 2 is my common factor. X squared minus 3 was the GCFs I took out. And of course, 4x squared was the GCF to start with. Number 3 is 2x to the fourth minus x squared minus 15. So a times c is 2 times negative 15, which is negative 30. So I need the two factors that multiply to equal negative 30, and the same two factors that add to equal negative 1. That would be your b value. This is going to be negative 6 and positive 5. Now I can rewrite this as 2x to the fourth minus 6x squared minus plus 5x minus 15. I said that wrong. So let me reread this. 2x to the fourth minus 6x squared plus 5x squared minus 15. Group your first two, group your second two. GCF of the first group is 2x squared. Left over is x squared minus 3. GCF of the second group is positive 5. Left over is x squared minus 3. Common factor, greatest common factor. X squared minus 3 multiplied by 2x squared plus 5. This is your factored answer. So far, we've been going over problems that are very straightforward. And when you get to this point, what I'm about to highlight, so when you get to this point, you're completely factored. However, there are going to be problems like number 4, where you can continue to factor. So you can factor this multiple times, and I'll explain how you recognize that. So you know that you can factor this right here. We're going to add in a 0x squared term. I'll write that in a second, but notice that 81 is a perfect square. So when you have something like that and you have a subtraction sign, it's called difference of squares, and you can actually use that formula right there. I'm going to skip using the formula just so I can show you how to do out the full method, but that is a process that you can use. I'm going to rewrite this as x to the fourth plus 0x squared minus 81. So all I did was add in a 0x squared, which does not actually change the value of the problem. It's just a placeholder. So now I need to know the two factors that multiply to equal negative 81 and the same two factors that add to equal 0. You're going to have positive 9 and negative 9. So again, when this happens, when you have a perfect square, you're going to be able to factor this multiple times. I can rewrite my expression as x to the fourth plus 9x squared minus 9x squared. These add to 0, minus 81. GCF of the first group is x squared. Left over is x squared plus 9. GCF of the second group is negative 9. Left over is x squared plus 9. I can write this as x squared minus 9 times x squared plus 9. Now, anytime this happens, if you have a value of x squared and you are subtracting a perfect square, just like we did up here, so same type of problem, you can factor this expression again. So what two factors add to negative 9 multiply to negative 9 and add to 0. You're all going to tell me that's going to be x plus 3 times x minus 3. So you have to be on the lookout for this happening. X squared minus a perfect square. So a perfect square, 4, 9, 16, 25, 36, 49, and so on. Anytime you are subtracting and then a perfect square, you can do this. This right here, you can't factor that any further because you need to think to yourself, if you were to try to do this, it's not going to work, but if we try to, what two factors multiply to positive 9 and the same two factors that add to 0? Well, my factors of positive 9 are positive 3 and positive 3, but add those together and you get 6, so that doesn't work. Or negative 3 and negative 3, add those together and you get negative 6, so that doesn't work. So there are no factors that will do this for you. So this second expression, it just remains the same, x squared plus 9. The only time that you can do that factoring process that I just explained is when you are subtracting a perfect square. All right, and the last example here, we have 84 times x to the 4th minus 16. So 84 and 16 have a common factor of 4. When we take out a factor of 4, we're left with 21. Sorry, I'm just thinking about this problem. Take out a GCF of 4, you're left with 21 times x to the 4th minus 4. All right, we are subtracting a perfect square. So let's just see if we can go further with this. We need to write this out as 21 x to the 4th plus 0x squared minus 4. 21 times negative 4 is going to give us 84, negative 84. So are there two numbers that multiply to negative 84 and the same two numbers that add to equal 0? And if you think about this for a minute, there are not. The only time that will ever happen is if this number is also a perfect square. So that way you can add and subtract the same number. This does not work. So we cannot factor this. So that means our final answer was just taking out the GCF, and that's it. And you're going to see problems like this on your homework or on quizzes. You have to check for a GCF. It's the first thing you always do, and it might be the only thing you have to do. So first thing, look at your graphic organizer. The first thing you do is check for a GCF. That might be the only thing you do. All right, I'll go over the on your own section during the live session at the end of class. Email me if you have any questions.